Hello, welcome to the second session of the first chapter, that is the introduction to statistical quality control. So here the main objectives of this statistical quality control for this unit is that to know the basic knowledge of statistical control and to understand the basic knowledge of statistical control. Now let us discuss the points that we have discussed in the previous hour. We have discussed about the objectives, the course outcomes of the last sessions, and they have given the introduction to SQC. Then I have told you what exactly is SQC, how the SQC is categorized, and then we studied something about the multi-choice questions and the reference books and the summary in the last class. So for the second session, the second hour, the first point that we have to study is that the goals of the quality control. What are the goals that we need to study here? So the goals of the quality control in every production system is that is one, they eliminate unconformities and their consequences. So there should not be any non-conformities. That is, whatever the productions that you would do, so you have to do with everything, finalized. Everything, if everything is correct, if the process is under the control, everything like machineries are maintained, all those things. If it is everything is confirmed, then only we can go for the production process. And the second goal for this is that the we have to eliminate the rework. There should not be any rework. Rework in the sense the dimensions of the product should not be over the dimensions. For example, the mean diameter of a shaft. I'll take the example of a shaft, a machine, a, a, a company or a machine is manufacturing a shaft whose diameter is say 20 millimeter. And if the machine is giving about 20 millimeter dimensions, so then we have to go for the rework. So the rework should not be, as far as possible, we have to see to it that the process should be under control and it should produce the components so that there should not be a rework. Then the second point here, it is that the waste resources. So as far as possible, when the machine starts to produce the component, as I've told you, an example I have given, that the machine is manufacturing a shaft whose diameter is 20. And say if the machine is manufacturing the ultimate product of the machine that is manufacturing and whose dimension is less than 20 millimeter, so then naturally that the product will be a waste product. So then we have to waste such products. That's why we should take care in such a way that the machine should produce, okay, the machine should produce the product within the limit, say 20. So 20 millimeter is the diameter of the shaft. So it has to produce 20 millimeter of the diameter of the shaft with some tolerances, plus or minus. So in terms of the microns, it has to produce. So here, that's what the second point says, that eliminate the rework and the wastages. So there should not be any wastages and there should not be any rework. So then only it is possible to achieve these goals at the lowest possible cost. If we maintain these things, that is, if there is no rework, if there is no wastages, so then we can produce the product with the lowest possible cost. So this is the the goals of the quality control. So the next one is what exactly is quality control? So in that, so first we should discuss about the quality. Quality, I can say that quality is fitness for use. We think in terms of good or excellent. We think in terms of good and excellent for our usage. But in the industries, quality product is one that fulfills the customer's expectations, and these expectations are based on the usages and the selling price of the product. So that is the quality. Then the control. What exactly is the control? So it is a process of regulating an activity to verify its performance to a standard to make the corrective actions required. So it means that so during the process, if anything went wrong, so then it is a duty of the quality control inspector. He has to immediately inform the operator that the the process is not under control. So then the operator, he has to bring the process under control. So so that if he brings the process under control, so then the process will be under control, and then we are going to get the quality products. So the next one is, what is the quality control? So we have studied quality, and then we have studied the control. Now, both together, we have to study the quality control. So now quality control is a regulatory process for those activities which measures the product's performance, compare that performance with the established standard, and make the corrective action regardless where this activity occurs. So so ultimately now we have to define in the last, uh, previously, as I've told you what exactly is the quality, and then I have told you uh, the control. Now we have to define the quality control. So the quality control is nothing but it is a process. It is a process where we have to take, if the process is under control, there will not be any problem. We are going to get the quality products. But if the process went wrong, if there is a uh, the under dimensions or over dimensions products are producing, if the process is producing, so then we have to compare that one with that is what the performance we have to compare with the established standard, and we need to take the actions regardless where these activities is taking place. So that is called as the quality control. So now we have to study, uh, put together the quality, then control, and then statistical. So we have to put together and we should define what exactly is statistical quality control. So the statistical quality control is a branch of the quality control. It is nothing but the collection of the data. So whatever the data is there, so we need to collect it, analyze the data, and then we need to interpret the data to control the quality and using the tools of statistics. So here we are using many statistical quality control tools are there, like for example, descriptive tools, where we are using by using the descriptive tools, we are finding mean, mode, standard deviations, all those things. And then there are some statistical tools are there, like control charts that you are studying in future. Control charts, then acceptance sampling are the tools. They are the main basic tools we are using here. By using uh, these tools, so where whatever the data we will collect, so we are going to analyze and interpret the data and will bring the quality of the product. So the third point is, what exactly is the quality control? The ultimate aim of the quality control is to provide an economic means of attaining, maintaining, and checking the objective standards of the quality. So here, the main purpose is always during the process, we are supposed we are supposed to attend, we are supposed to maintain, and we are supposed to check the objective standards of the quality during the process. That is called as the statistical quality control. The next point that we are studying is that what exactly is the difference between the normal inspection versus the statistical quality control. So now, first, let me discuss is the normal inspection. What exactly is a normal inspection? A normal inspection is an inspection. We are using such inspection where it is not, we are not using this normal inspections in the repetitive productions or in the mass productions, because it is 100% inspection here. Here the inspector is going to inspect each and every dimensions of the product. So because of this, the normal inspection, so it is results in separations of the defectives, because if you see the link one, the first point and the second point, the first point is connected to the second point, because the results in separation of the defective, it is only because of the 100% inspection, where the inspector is determining, finding the dimensions of each and every parts of the dimensions he is finding. And if there is if there is it is not meeting with the standard dimensions, then the inspector is going to reject the component. So there is a waste in the material. So that will come to the next point. So so the normal inspection is because of the 100% inspection and the time consuming. So because of that, so there is a result in separation of the defectives. And as here it is the cost of this inspection is more, because each and every part he is going to inspect, that's why the cost is more, and the time taken is also more. Then the next point is inspector function is passive and active, because he has to involve, he will be involving in finding the dimensions of the product. So he will not be free here. So he will be always active here. So that's why the inspector function here is passive and active. And there is a material waste. As I've told you that because of the 100% inspection, so inspector, if there is a variations in the dimensions, so the inspector will reject the component. So once the component is rejected, so there is the waste of the material. So these are the points, that is 100% inspection, that results in the separation of the defective, more cost and more time, and inspector functions is positive and active, and the material wastage. So these are the main points of the normal distribution. When we now we'll compare these points with the statistical quality control. So if you see the statistical quality control, it is a sample inspections. If you see there, that is in the normal inspection, it is the 100% inspection, where each and every component part will be inspected. Whereas here, it is a sample inspection. What do you mean by the sample inspection? So a sample inspection is one where the inspector is going to take a sample size of say 5, 6, 7, and he is going to inspect it. But because it is you basically this SQC is used in the mass production process, and in the mass production process there will be, the machine will be giving its output will be in terms of hundreds, 200s, like that, and it is very difficult to the inspector to inspect all the 100 items, so in a time span of say 1 hour. So that's why here SQC is a process where we are taking the sample of size say 4 5. It is depends upon the agreement between the inspector, the agreement between the customers and the producers. So that's why if you take this, so out of 100, the inspector is going to inspect only 4 to 5 or 5 to 6 items, but he is not inspecting remaining items. So depending upon the agreement, so the lot will be accepted or it will be rejected. That is the first point. When you go to the second point, so here there is, you know, results in preventions of defective products formation. So naturally, say in a mass production, a machine is manufacturing 100, say 100 items in 1 hour, and out of the 100 items, the inspector is inspecting only 5 or 6 or 4 items, and the decisions will be taken on the basis of the sample size. So that's why he is not inspecting. Say, for example, out of 100 items, he has taken only 5 items for the inspection. But here he is not inspecting remaining 90 items. So, so we doesn't know what is the condition of the 90 items. Just we are inspecting only 5 items. So that's why this is results in the preventions of defective. 95 items we are not inspecting. So what does it mean? It means that it is results in the preventions of defective products formation. So that is what, when you take, the normal distribution, you see a results in separation of the defectives. So in a normal inspection, results in separation of a defective because of the 100% inspection. But here it is a sample inspection, so results in preventions of the defectives, products formation. Here the cost of the inspection is less and the time is less. He is not going to inspect all the 100 items. So that's why he is just inspecting the sample, and to inspect the sample, it needs the less cost and the less time. Then the fourth point, the inspector function is active, productive. It is active and productive. When you go to the normal inspection, it is a passive and active. But here it is the productive. So the inspector function is the productive function. And when you take the fifth point, that is the minimize the material waste. So because of the sample inspection, as I've told you, that 95 items out of 100 will not be inspected. So that's why the here the wastage of the material we can minimize. But in the normal inspection, when you take the normal inspection, so there is a material waste. So these are the 5 points here. They are basic difference between the normal inspections and the statistical quality control. But apart from these 5 points, when you take the remaining, say there are 3 points are the statistical quality control. They are never going to apply in the normal inspections. That is the 6 point, reduce producers inspection. Why the producers inspection will be reduced? Because so there will be an agreement between the customer and the producers. So a inspector has to take a sample, and when he inspect, and because of the agreement between the consumer and the producer, so here either the here the customer is going to select the whole lots depending upon the inspections. So that's why there is no question of inspections by the reduces, the producers. Okay, so it reduces the producers inspections because he is not the 100% inspections. The next point is tool setter, machine shop operator, actual take the interest in quality charts pasted along the sides of the machine. It is only because there is a bonus scheme. That is the next point. So because uses of the control chart, next point 8 is uses of the control charts leads to quality bonus scheme. So because of this bonus scheme, here the 7th point says that the tool setter machine shop operator actually take the interest in the quality control because it is one advantages for them. And because of this bonus scheme, so they will take actual interest in the quality control charts that has been pasted alongside their machines. So that is the main difference between statistical quality control and the normal inspections. Once again, I'll tell you what is the difference. So in the normal inspection, it is the 100% inspection results in the separation of the defectives, more cost and more time. So inspector function is passive and active, and there is a material waste. Then when you go to the SQC, it is a sample inspection, and there is a results in preventions of the defectives products formation, and the cost of the product is less and the time is less. And the fourth point is inspector function is active and productive and minimize the material waste. And the remaining 3 points as far as SQC is concerned, so reductions in the, there is no chance of producers inspections, and the tool setters and the machine operators will actually take the interest on the chart that has been pasted on the machine. It is only because of the use of the bonus scheme that they are going to get. So that is the difference between the normal inspection and SQC. Now, we will study what exactly is the applications. What exactly is the applications of SQC? Basically, it is SQC is not the normal inspection where the 100% inspection will be taking place. So it is SQC is a sample inspections. So that's why this inspection technique is applicable to to the manufacturing unit organized on a mass production basis. So we cannot use this one in a, you know in a production process which is running at 3 light shifts. So the main application of the statistical quality control is it is on in the mass production basis. So where there is a mass production, so we are using statistical quality control. So it is the first application of the statistical quality control. So the statistical quality control, it is mainly used in the mass production. Next, where exactly again we can use? Hey, say for example, a process is there where it is a repeatedly a, a machine. It is manufacturing repeatedly the same productions, always the same production. It is for the repetitive productions, we are using the statistical quality control, or either in a continuous flow or batch flow. So we can use this statistical quality control. We are using this statistical quality control basically in a 3 production processes. So one is called as the mass production, and the second one is called as the repetitive production, and the third one is called as a continuous flow or the batch by batch production. So when we use the SQC in these above processes will prove to be ultimate benefit. So there is a benefit. So that's why we are using statistical control for these 3 types of the productions: mass production, repetitive productions, continuous flow, or batch productions. So SQC is not economic. This is not economic. If an individual batch runs less than 2 10 hours shift, there are 2 shifts will be there, and each shift is running for 10 hours or 3 light hour shifts throughout the production processes. So that's why here we cannot apply the statistical quality control for a batch runs less than 2 hours, less than 2 10 hours shift or 3 light hour shift for the production processes. So that is the main applications of SQC. Now, we'll discuss some multi-choice questions here. The first multi-choice question is that what are the 2 basic categories of the quality? So now here, the first option is design conformance quality. Second one is good or bad quality, defective and non-defective quality, attributes and variables. So when you go to the design and conformation quality, so which is not, categories of the quality. When you think a quality, so we will think the quality in terms of good or bad. Okay, either it may be a good or it may be bad. So we will not think about here the customer's expectation is what the expectation is what the quality should be good. So the answer for the first multi-choice question is that, so for the what are the two basic categories of the quality. So the categories of the quality is the good or bad. So they will think either it will be a good or it will be a bad because of the sample inspection. So the second multi-choice question, statistical quality control is best described as, as one, keeping product characteristics within certain bounds. B, calculating the mean and the standard deviation. Third one is study of the characteristics of the products or process with the help of the numbers to make them behave the way we want them to behave, and the implementation of ISO 9000. So when you take this, the statistical quality control is best described. We can't say that keeping the product's characteristics within the certain limits. No, the statistical quality control is the best described by means of the third option here. Okay, that is the study of the characteristics of the product or the process. We need to study here the characteristics of the product and the process with the help of the numbers, that is the statistics, to make them behave the way we want them to behave. So this is the actual study of the statistical quality control. Implementations of ISO 9000 comes after we are getting the quality products. And then the calculating of the mean and the standard deviation is the descriptive type of the statistical quality control. So for the second, the best answer for the statistical control is the third C, that is called as the study of the characteristics of the product or processes with the help of the numbers to make them behave the way we want them to behave. So that is the second multi-choice question. Then the third multi-choice question, the word dash represents the properties of the product or the services that are valued by the consumers. So one is control, B is quality, C is standard, D is statistics. Here, consumer, consumer always, he will not think about what type of control has been used. He will not think about what type of the standards that has been used as a reference standards. He will not think about what type of statistics that has been used. He will think only in terms of the quality. So the answer for the third objective, multi-choice question is nothing but the quality. So I'll go for the descriptive types of the questions. So here, as I've explained here, so we need to explain, we need to study what exactly we have studied in this second session. Explanation of statistical quality control is a descriptive question. So here you need to define first the quality, then you need to define the control, and then you need to define statistical quality control. So that is a descriptive type of the questions you need to study. So once again I'll repeat, you have to first define quality. So fitness for use, as I've told you, then control. So the inspector need to bring the process under control with the help of the statistical data that has been collected and that has been transformed into the charts that has been pasted on the machines. And by seeing the charts, the operator will try to bring the quality. He will be referring the charts that has been pasted on the machine, so that because he will be getting the bonus out of that. So he will be always concentrating on the quality. So that's how you are supposed to explain what exactly is the statistical quality control. Then the second point, the second descriptive question is that what is the difference between the normal inspections and SQC? As I've told you, there are main five differences between the normal inspection and SQC. In the normal inspection, as you know, as I've told you that, so it is the 100% normal inspection is the 100% inspection, okay, and in the 100% inspection, so there is a results, results in separations of the defective, and the cost is more and the time is more. And inspector's function is passive and active, and there is a material waste. Whereas SQC, when you see if the first 5 points of SQC, when you see sample inspection is there is a results in preventions of the defective, cost is less and time is less. Inspector function is active and productive and minimize the cost of the minimize the material waste. And then in the descriptive type question, so that is the 5 points are the main differences between the normal inspection and the quality control, that is the statistical quality control. But in addition to these points from the normal inspection and SQC, you need to add another 3 points. That is, there are 3 points in the SQC. That is, there is no question of inspection by the producer, and the tool maker and tool setters and the operators will be always concentrating on the charts that has been pasted on the machine. It is because they are going to get the bonus scheme. So because of this bonus scheme, so they will take more interest on the chart that has been pasted on the machines. So that's why this is what the main difference between the normal inspections and the SQC. The third point, the third descriptive questions here is that applications of SQC. Where exactly we are applying the SQC? As I've told you that SQC is in the difference, I have explained you in the difference between the normal inspection and SQC. So SQC is a sample inspection. It is the sample inspection. So that's why it is mainly applied in three fields. One is called as the mass production. We are using this statistical quality control. We are using the statistical quality control in the repetitive manufacturing process, and also a batch by batch production process. Basically, we are applying the statistical quality control in these three fields, but it is not economical when a batch runs 2 shifts of 10 hours or 3 night shifts, where the SQC will not give the benefits. So it is benefited only in the three field. One is called as the mass production, the second one is called as the repetitive production, and the third one is nothing but batch by batch productions. So that is about the repetitive question. So thank you for hearing me. Thank you. Is that? Is that? Is that? Is that? Why?